All right, so let us talk in this video about what the second derivative is. Okay. All right. So I've talked about what the first derivative is. Um, well, we've done in videos how to find it, as well as a video that I have that I call "What does the derivative mean?" Um, But second derivative is going to take those visualization skills to the next level. Visualization is a big part of calculus. And so we're going to have to really visualize even more to kind of figure out what the second derivative is. So first of all, think about this. We know that the first derivative, and let's write this down. The first derivative, which, we can also denote that as f prime, is the slope of the original function. Second derivative, all the second derivative is with the original function, you take the derivative once and then you take it again. The second is the second derivative. So if the first derivative is the slope of the original function, the second derivative, which is denoted by f double prime, is the slope of f prime, the first derivative. Okay. So with that said, let's think about this. We know that if you take the derivative of a function, if that derivative is positive, okay, we're gonna write that here. So so if the first derivative is positive or greater than zero, the function is increasing. Okay. And if the first derivative, I just draw some lines here just to kind of like separate this out so it's not too jumbled up and all that kind of stuff. So if the first derivative is less than zero, the function is decreasing. Okay. Now, that said, let's apply those same principles to the second derivative. So if f double prime is positive, that has to mean the first derivative is increasing. If f double prime is less than zero, that means that the first derivative is decreasing. Okay. So pretty self-explanatory so far. You figure if the second derivative is the slope of the first derivative, just like the first derivative is the slope of the original function, then all these things kind of have to be the same. They parallel each other. Pretty straightforward. Now, here's where we need to take this stuff right here to the next level. Now, what we want to do is we want to connect the second derivative to the original function. So you got original function, first derivative, second derivative. So now we want to connect the second derivative to the original function. So I'm gonna need some space here. All right. I'm not sure why. Well, I must not have had it highlighted. All right, so let's do this here. I'm going to draw a few pictures. Um, let me draw. I'm going to do like this. Now, say that we have a part of a function that's like so. Actually, this is not the function. This is actually still we're using the first derivative, but we are still, keep in mind, we are comparing the original function to the second derivative. Now, let's think about this. if this is the first derivative, and this is a part of the graphing of the first derivative, what this is saying is at this part of the function, the derivative is negative. The derivative is negative. Okay. Okay. So so let's think about this though. So if the the derivative is negative, but we see that the slope of the derivative line is increasing. So let's make sense of this here. If the first derivative is increasing, but it's negative, so let's write this down. If f prime is increasing, but less than 0, the slope of the original function is negative. Okay, let's stop there. So if this is the first derivative and it's obviously increasing, that means, of course, that f double prime is positive. But if f prime is increasing, but it's less than 0, as you see here, remember, if the first derivative is negative, then that means that for the original function, the slope is decreasing. But because the first derivative is actually increasing, and let me make sure I get this right, because the first derivative, it is negative, but it's increasing, it's actually coming to 0, then that means that the slope, because the slope, that this is actually about to become positive. So what's happening is, if you can visualize this, let me actually try to draw here separately the original function. So think about this. This right here is saying that the this is f prime, and it's f prime is negative, but at the same time, f prime is increasing as well. That means the second derivative is positive. Now, if the first derivative is negative but increasing as it approaches 0, then what's happening is the slope of the original function, this is the original function, the slope of the original function is doing something like this. It's negative, but as it's nearing 0 and about to go positive, it's about to bottom out here. You see? Now, once let's do this here. Let's go ahead and bring this across the line like that. And this is a very simple illustration here, a very simplified example. So let's think about this here, and I'm going to need this space again. So let's erase this. Make sure you take notes, okay? Now, so we've just crossed the line. Let's get our black. So now, if f is increasing, f prime, I mean, is increasing, and it crosses the x-axis, so what that means is you have a negative first derivative, then you have so it's a negative slope for the original function, 0 slope. Now you have a positive slope as you start to go positive first derivative. So it crosses the x-axis. Where it touches the x-axis is where function transitions from negative to positive. Okay. So this was stage 1. And for the original function, this is stage 1 as well. So when you get here, This is stage 2, where you cross the x-axis. Where you touch the x-axis, the original function bottoms out. Because you think about this, the first derivative is 0 here. That means the slope is 0. It's horizontal. And then it goes positive. So that means the slope starts to increase. So it's kind of like this right here. Is this the color I used? Okay. Okay, so that's the corresponding stage 2. So what's happened is you've bottomed out and you start to go positive. Okay. Now, finally, we're going to have this continuing to increase. And let's think about it here. So what's happening here is the first derivative is still increasing. It's positive and it's increasing. So what does that mean? So first of all, if it's increasing, that still means that the second derivative is positive. The second derivative is positive. The first, which means that the first derivative is increasing, and because the first derivative is positive, that means that the original function is increasing. Okay, and so what happens is, okay, let's see, get my color back. In stage 3, what you have is, I thought oh man, I knew it was gonna do that. Oh boy, sorry, it's kind of acting up a little bit. So let me get my blue back here. So this is kind of like this. This is up here. So this is 3. This is 3. So the first derivative is still increasing. That means the second derivative is positive. And because the first derivative is positive, that means that the original function is still increasing. So it's getting steeper and steeper for the original function. Now, all of that said, let's write this down. If f prime, the first derivative, is increasing, and greater than 0, hold on a second here. The slope of the original function is becoming increasingly positive. So all that means is, because the first derivative is still positive, that means that the original function it's positive, it's going up. So that means the original function is increasing pretty quickly. That it's getting steeper and steeper. So that means this is going to start to go more and more up as a straight line, because this is steadily increasing. Okay, so if this leveled off, if the slope ended up being a 0 slope, I mean that's not what I mean to say. If f prime leveled off, then that means that you would have a positive slope that's not changing. So that means it'll be a constant slope. And so this would just kind of go in a straight line, like diagonal, like. But because it's like this, then this is just going to get steeper and steeper and steeper until it looks like a straight line. So all of that said, in all of these examples, what is true of the second derivative? Okay, I see that second was erased. What's true of the second derivative in this case is that the whole time, the second derivative being the slope of this first derivative, it is the second derivative is positive, because the first derivative here is increasing. That means the second derivative is positive, since the second derivative is the slope of the first derivative. So all of this being true of the second derivative, if we look at what happened when the second derivative was positive, that means that this. So if the second derivative is greater than 0, the original function F is what we call concave up. In other words, it's that U shape that's pointing upward. And then finally, I'm not going to go through it all in this video, but you can go through and think about it yourself if you would like. This is true. If f double prime is less than 0, the second derivative is less than 0, then f is going to be concave what? Down. You see? So we went through a lot to do this here. And it's a little interesting to visualize this, but it's a good exercise. It really helps to exercise your brain, and it shows you what I mean when I talk about how visual calculus is. You really have to kind of like it's almost like it's multidimensional and stuff like that. It's pretty cool. And it's a good exercise, okay? So if you want to go through and see the whole concave down thing, I invite you to do it on your own. But it's really just the reverse of everything that we talked about here. All right. Make sure you share this and watch it as many times as you need to understand it. And if you have any comments, leave your comments.